Hello users and judges. I, Sujit Prasad Banerjee, on behalf of AxisVision, is going to present you our model that is OmniML, an autonomous HITL that is human into the loop AutoML pipeline. So what it does is that it will create a machine learning model for you without any human intervention or minimal human intervention. So if I suggest here, I need an AI model to diagnose whether a patient has breast cancer based on the static biopsy records and tabular cell measurement, find me a data set and build the optimal architecture. So it will build me an optimal architecture. It will suggest me data sets from Kaggle. We have used the Kaggle API and as well as the Hugging Face API to fetch the data sets. And if we just press enter up here, our model, our LLM that we are using here is Grok, will suggest me an architecture if we ask him to suggest. So it's thinking right now, it's processing, and boom, here it suggests us. So input, here's layer 1, here's layer 2, here is layer 3, layer 4, and here goes the output layer. But here we will make the last layer just to show you that how it works. So you can just drag and drop the layer up here. You can do a fun interaction and connect. Boom! And now what we'll do is that we will validate our graph. Yeah, it's checked. Then we will just go for this finish architecture. And let's see, we have 7 layers in the architecture, and boom, here we get our datasets from Kaggle. So here are 3 datasets. We can just click one and we can see that, okay, so I should work with this because it has 125 KB of data right now with us. So what I will do is that I will select one. It will download the datasets. Let's wait for some time to download the real data, because we don't have any idea that how this data works. So it will give us an EDA, that is exploratory data analysis. Here we can see the radius mean, the texture mean, the perimeter mean, area mean, smoothness mean, compact mean, radius, and every other details. 569 rows, 33 columns, 15 numeric, and 1 categorical data. So here you can see the correlation heat map, top feature correlations, and the AI data insights. So what we'll do is that we will proceed to train our setup. Once we click, we are up here to configure our training run. So here we will just set the epochs to 5 because we need to build this model in a very short time. So what we'll do is that we will go to test size as less as 10%. You can see the test size is as low as 10%. And boom, let's save the configuration. And then without a single line of code, I will run it on my, boom, you can see here. So as it already stored in the cache, so here it comes our loss curve, our accuracy curve, and the value which has been lost up here while training the model, and then it goes for the AxisVI. So what does Arix or ArchiveV does is that it compares the research papers on ArchiveV, and it compares with our research paper, and it brings us the fault that we have in our paper. So this is what we have built. Just wait for some time till it gives us the scholarly benchmarks. And boom, here we can see an optimal architecture. Okay, here are a lot of data as we can see. Then here we can go to the methodology. Okay, so these are all the differences, a lot of theoretical data for the users who are more diverted into the theoretical part. So this is our project. I hope you have liked it. Thanks a lot.